Introduction hook. Have you ever wondered why speed and velocity aren't the same? Or why temperature has no direction? In this video, we'll explore scalar quantities, their characteristics, and give you 20 real-life examples. A scalar quantity is a physical quantity that has only magnitude but no direction. 1. What is a scalar quantity? A scalar quantity is completely described by its magnitude alone. Unlike vectors, scalars don't have direction. 2. Example comparison: speed, scalar, versus velocity, vector; distance, scalar, versus displacement, vector. 3. Visual aid: show a car speedometer, shows magnitude but no direction. Show a compass with direction, to contrast vectors. 20 examples of scalar quantities. 1. Basic scalars in daily life. 1. Time, always moves forward, no direction. 2. Temperature, can be hot or cold but has no specific direction. 3. Mass, objects have weight, but weight itself is a vector. 4. Distance, only the total length matters, not direction. 5. Speed, measures how fast something moves, not where. 6. Energy, measured in joules, has no direction. 7. Work done, scalar because it depends on force and displacement but not direction. 8. Power, the rate of doing work, watts. 9. Density, mass per unit volume, no direction involved. 10. Pressure, force applied per unit area, acts in all directions equally. 11. Volume, space occupied, no directional dependence. 12. Luminous intensity, brightness of a light source, candela. 13. Electric charge, measured in coulombs, does not have a specific direction. 14. Electric potential, voltage, energy per charge, no directional component. 15. Entropy, measure of disorder in a system, no direction needed. 16. Specific heat capacity, energy needed to raise temperature. 17. Magnetic flux, strength of a magnetic field passing through a surface. 18. Wavelength, distance between two peaks of a wave, no direction. 19. Refractive index, measures bending of light, scalar in nature. 20. Electric resistance, opposition to current flow in ohms. Show text overlays or animations for each example as you go. 3. Why are scalars important? 1. Scalar quantities help in measurements and calculations without worrying about direction. 2. Essential in thermodynamics, electronics, mechanics, and everyday life. Conclusion: scalars only have magnitude, while vectors have magnitude and direction. Title: Vector Quantities. Introduction hook. Have you ever wondered why velocity is different from speed? Or why force needs both strength and direction? In this video, we'll explore vector quantities, their characteristics, and 20 real-life examples. A vector quantity has both magnitude and direction. Unlike scalar quantities, vectors tell us not just how much but also which way. 1. What is a vector quantity? Vector quantities are physical quantities that require both magnitude, size, and direction to be fully described. 2. Example comparison: velocity, vector, versus speed, scalar; displacement, vector, versus distance, scalar. 3. Visual aid: show an arrow representing vectors, length equals magnitude, direction equals orientation. Show a car moving with both speed and a direction. 2. 20 examples of vector quantities. Rocket, basic vectors in motion. 1. Displacement, shortest path between 2 points, for example, walking from A to B. 2. Velocity, speed with a specified direction, for example, 60 km/h east. 3. Acceleration, change in velocity over time, for example, car accelerating forward. 4. Momentum, mass times velocity, has both magnitude and direction. 5. Jerk, the rate of change of acceleration, for example, sudden braking in a car. Flexed biceps, force-related vectors. 1. Force, a push or pull in a specific direction, for example, pushing a box forward. 2. Weight, the force of gravity acting downward on an object. 3. Tension, force transmitted through a rope or cable. 4. Friction, opposes motion in a specific direction, for example, car tires gripping the road. 5. Thrust, forward force in rockets and jets. Africa, physics and engineering vectors. 1. Torque, a rotational force applied at a distance from an axis. 2. Electric field, a field exerting force on charged particles. 3. Magnetic field, describes the direction of magnetic force. 4. Angular velocity, rotation speed with direction, for example, spinning top. 5. Angular acceleration, change in angular velocity over time. Basketball, everyday life vectors. 1. Lift force, the force that allows airplanes to rise. 2. Drag force, air resistance opposing motion, for example, parachute slowing down. 3. Wind velocity, measures wind speed and direction, for example, 15 km per hour north. 4. Current in water, describes the flow of water in rivers and oceans. 5. Gravitational field strength, the strength and direction of gravity at a point. Use text overlays or animations to visually highlight each example. 3. Why are vectors important? 1. Vectors help describe real-world motion, forces, and physics phenomena. 2. Used in engineering, navigation, sports, and space science. 3. Without direction, many calculations in physics wouldn't be accurate. Conclusion. 1. Recap. Vectors have both magnitude and direction, unlike scalars which only have magnitude. 2. Call to action. Now that you know 20 vector quantities, can you think of more? 3. Comment below. 3. And don't forget to like and subscribe for more physics videos. 4. Power of knowledge vision.